Very good evening, everyone, and welcome to the Amateur Radio Technician class, session number 12. So looking at the curriculum, we can see that we have been progressing nicely, so much so that there are really just 2 more topics after today to complete our syllabus. So this is where we are in the list of all of the topics that we have to cover under the technician class. Last class, we looked at the maximum permissible exposure limit, RF exposure evaluation. We looked at what the power supply wiring would be like. We talked about the minimum current capacity of a power supply. We again looked at connecting a computer with amateur radio equipment. We also looked at those connections between the computer and the radio, the role that the sound card plays. We looked at a component known as the ferrite choke. We discussed the flat strap. We looked at what causes alternator whine. We looked at the feature on a radio called the noise blanker, and other features as well, such as the microphone gain, the keypad / VFO, memory channel, scan, and squelch. We also looked at the repeater offset. We also looked at the receiver incremental tuning, or RIT, and the / also called the clarifier. We looked at AGC, or the automatic gain control, also the receive filter bandwidth. We looked at what the PTT, or push to talk, was, and we stopped at page number 59 in the no nonsense guide. We did not have any questions from last class, so we move along. So let us look at what a transceiver is. Throughout the several sessions, we have been using the term, and we have been putting up pictures and saying, you know, hey, this is a transceiver. But what exactly is a transceiver? It's really, if you look at it, it looks like 2 words squished into one, transceiver. And that's exactly what it is. A transceiver is a receiver and a transmitter combination. So back in the days, early days of amateur radio, someone will have a receiver, piece of equipment known as a receiver. And this is a block diagram as to what a receiver would involve. You have an antenna, you have various stages and components to the point where you have a speaker and you'll hear transmission. And you also had a transmitter where you would speak into it or apply a signal and it will process and go out through your antenna. There used to be discrete devices or discrete pieces of equipment. But in today's world, they have merged the two together, and we now really talk about a transceiver. But it should not be lost upon us that it is still within the piece of equipment, even though it's one device, there's a receiver and there's a transmitter. So we say a transceiver is really a combination of a receiver and transmitter in one. And if we were to look at the bottom of our slide here, we will see examples of transceivers. This is an HF transceiver, for example. And on the right-hand side, we have an example of a UHF or VHF transceiver, also called simply a radio. So we're introducing a new term, sounds a little bit unusual, transverter. So we may not have come across that term before. So let's see what a transverter is, and you need to know the function of it for your amateur radio exam. A transverter simply converts one frequency or one frequency band to another frequency or another frequency band. That is what a transverter does, and it does it in both directions. So in the middle here, you see an example of what a transverter looks like. And you see on the left-hand side, we have a radio that's operating on the HF band, example 28 megahertz. And on the right-hand side, we see we have an antenna connected to the transverter. So the transverter will take a radio transmission on one band, let's say the HF band, convert it to another band, let's say the 2-meter band, so 146 megahertz, and send it out to the antenna. And it will do the opposite. It will take frequency input of, let's say, 2 meters or 146 megahertz and convert it down to the 28 megahertz frequency that this radio could receive. So this radio on its own, on the left-hand side here, cannot do VHF or UHF. It can do HF, right? But if you wanted to do VHF or UHF, you connect it to something called a transverter, and that device enables your otherwise HF only radio to be able to do VHF or UHF or some other band. So that's the purpose of a transverter, and that's how it's connected to your radio. Now just bear in mind that this radio is an HF radio only. Nowadays, you can get combination radios that does HF, VHF, and UHF all in one. But the point is, if you have an HF radio only and you want to do VHF or UHF or some other band with that same radio, you employ the use of a transverter. The other concept that we talk about is that of an amplifier. So picture a scenario. On the left-hand side here is a handheld device, or sometimes called a walkie-talkie, or an HT for handy-talkie. Looks very familiar, I guess. And we will use this to walk around and talk very conveniently. But one of the issues with handheld devices such as these, walkie-talkies, is that they tend to be low-powered devices, meaning that this handheld that we are looking at on the left-hand side of our slide only does about 5 watts maximum output to the antenna. But what if I wanted to do transmission at a further distance and I needed more power to get my signal even further? Do I have to change the radio? Well, I can use the same radio that would only give me 5 watts of output power and employ or connect that radio to an amplifier. And that amplifier will take my 5 watts that this handheld radio is capable of doing and could output 25 watts, 50 watts, 100 watts, depending on the specifications of the amplifier. So I can use my handheld device that's limited to 5 watts out, connect it to the amplifier, and end up with a higher power output going to the antenna. Note that this amplifier also has 2 buttons that will be on your exam question pool. A mode switch that we can select whether we are using FM mode transmission or if we are using single sideband transmission. And to answer your question, before you ask it, yes, even on 2 meters and 70 centimeter, we can do single sideband. We are not only restricted to FM in this frequency band, we can do SSB. So we need to tell the amplifier, hey, it's an SSB or single sideband transmission that is coming, so that the amplifier will know to key and hold, because that is how SSB transmissions are, very intermittent. So a mode switch allows the switching from SSB to FM. Also, another button allows the functionality of what we call a preamp or preamplifier. While the amplifier works in the output direction, it takes the transmission from the handy-talkie that's only doing 5 watts, amplifies the signal and sends it out to the antenna at about 100 watts or whatever it's configured to. The preamplifier works in the opposite direction. The preamplifier will take the signal coming in from the antenna into the preamp, amplify the incoming signal, and send it to your radio so you can hear a transmission better. So that's the difference here. The amplifier function and the preamplifier function. And you'll see questions in the question pool on those. Speaking about transceivers, transceivers do have specifications. The same way if I'm going to buy a pump, I am going to purchase a car, or any other purchase that I'm going to make of equipment, I may have some specifications. So for example, if I'm purchasing a car, I may say I would like a 4x4 vehicle, or I may need a vehicle with so much and so much horsepower, or maybe I need an engine size of 1600 cc's, and so on. So I may have some specifications when I'm procuring and purchasing any kind of equipment. Well, similarly, when we are in amateur radio and we're going to purchase our radio, whether we go online at HRO, Gigaparts, or Amazon, and we're looking for equipment, we need to be mindful of some specifications. For the technician class, there are a couple of specs that we need to be mindful of and what they mean. So for a transceiver, remember we said a transceiver is a receiver and transmitter in one. Sensitivity, again, sensitivity, right? The word sensitive, but sensitivity is one of those specifications. And it refers to the ability of a receiver. So we are talking about a transceiver, but we are referring to the receive section of the transceiver. So the ability of the receiver to detect the presence of a signal. That is the sensitivity. So if a radio is not sensitive, it may not detect the presence of a signal. All right, so here I just put up a little screenshot as to what a spec might look like for a particular radio. This is actually the spec from an ICOM 7300 radio. When you look at the specifications document, you'll see sensitivity and it will tell you what it is here. So this is an example of what sensitivity looks like in a spec sheet. And note that a graph of sensitivity shows that a radio may have high sensitivity and lower sensitivity across a spectrum of frequencies. So the sensitivity is not necessarily one figure. It may be different depending on the part of the spectrum or the band that the radio is operating on. So just bear that in mind. Just some further bullet points to further emphasize what sensitivity is, right? But for the exam, all you really need to know is the first bullet point. The rest of them are just further and better particulars or further explanation or the same information presented in a different way. So we also say that sensitivity is the ability of a receiver to detect the weakest possible signal. Again, if you think about when someone is sensitive, yes. Also, sensitivity is expressed in microvolts or decibels. So notice one of the specs that I pulled out here, you notice 0.16 microvolts. So just bear that in mind. You're not likely to get this on your exam, but we do a little bit extra in the class. So just in case you're wondering how sensitivity is measured, it's either microvolts or decibels. Also, sensitivity is dependent mostly on what we call the gain of the intermediate frequency or IF amplifier circuit in a radio. So that circuit in a piece of equipment, how well it's built, will determine the sensitivity. So the more expensive really that amplifier circuit is, better quality components, the more stages, the more sensitive it would be. All right, you get what you pay for, like so many things. Also, sensitivity is sometimes called the receiver threshold. All right, and we made this point a little earlier. The sensitivity often varies over the tuning band, so it's not necessarily you're sensitive in the same way for the whole band. You might have a higher and a lower sensitivity, which is what this graph on the right-hand side shows. Different parts of the band, you have a higher or lower sensitivity. The other specification that we talk about in radio, it's another receiver specification. It's called selectivity. The word select, but it's selectivity. But what is selectivity? So for the purpose of the exam, you need to know the first bullet point. Selectivity is the ability of a receiver to discriminate between multiple signals or to identify between multiple signals, right? So this section here shows a selectivity specification. Again, I think this is taken from an ICOM 7300 radio spec sheet. So this is what it actually looks like in a spec sheet. Also, this is a graph here that shows what selectivity is. It shows that for a particular frequency, there is no attenuation, meaning that it listens very well on that particular frequency, but adjacent frequencies either down or adjacent frequencies up, the attenuation increases, meaning that it rejects the signal other than what it's looking at. So it likes to select. So let's look at some other bullet points that will hopefully drive that point home. So selectivity is also the ability of a receiver to select a signal of desired frequency while rejecting all others. So in other words, it's like a filter. Selectivity is also the ability to receive, of a receiver, there should be receiver, my apologies, typo. So it's the ability of a receiver to differentiate desired signal from unwanted signal. So again, these are just other ways of saying the same thing, right? Selectivity is measured by the bandwidth of the tuned circuit. So if you look at the right-hand side here, notice it's giving us bandwidth. We note that the attenuation offered to the unwanted signals around the tuned frequency. So for example, we talked about this graph here as this is being the attenuation. So the desired frequency is this frequency here, and we have no attenuation or no reduction in the signal. But below the desired frequency and above the desired frequency, we have high attenuation. So it discards or it ignores those other frequencies, and it pays attention only to the center frequency. So that is selectivity. Right. So two other stages or components of a transceiver, and specifically a receive section of a transceiver that we need to know about, is called the mixer and the oscillator. So if we were to look at this diagram, we will see an antenna. This is a symbol for an antenna. We have a little low noise amplifier. Then we have something looking like an X in a circle. We call that the mixer. And we also have an oscillator that is connected to the mixer. And then there's a frequency that's output. So these are the stages of a receiver, or what we call a superhet or a super heterodyne type receiver. So the frequency comes in via the antenna, but the radio is not able to really make much sense of that very high frequency transmission. So what it has to do is take it in, and an oscillator inside of the radio generates a frequency and it mixes with the frequency that you're listening to. So that's how it works. You have the incoming frequency, you have an internal frequency generator, or it's called an oscillator, and a mixer combines the two frequencies to give an output frequency. And that frequency that is output is called the IF, or what is called the intermediate frequency stage. And that IF frequency is at a fixed frequency as well. The IF is always the same. So notice here, we show you a specification of a radio. Again, I think this is the ICOM 7300. The IF is 36 kilohertz. So no matter what frequency you want to tune to or monitor, the oscillator will generate a frequency such that the mixer will always generate the same 36 kilohertz out. So that's what this diagram shows here. We have the frequency that we're actually listening to being mixed with an oscillator frequency or generator that generates another frequency to create a frequency that we could actually listen to in our radio. And that frequency is called the IF stage or the IF frequency. So notice the components here. The radio itself will listen maybe 0.3030 to 74.80 megahertz. That's the receive frequency range, but it will always end up at a fixed frequency of 36 kilohertz at the IF stage. And how that is done is through something called a mixer stage and an oscillator that provides the right frequency. It generates that frequency at all times to ensure that the output here is always 36 kilohertz, no matter what the input is. So your input could be, you're listening to 14.250, or you're listening to 3.815, or you're listening to some other frequency on your radio. That's the tune that you're tuning that frequency to, but the oscillator will always generate a frequency to mix with your incoming desired frequency and output this, what we call IF. So you just need to know that what a mixer does, it mixes the incoming frequency with a locally generated oscillator frequency and outputs what we call the IF frequency. And the oscillator is what generates that local frequency that the mixer uses to mix with your incoming frequency to generate your IF. We had discussed modulation previously, but we will look at it again. Remember that we are talking about using a radio to speak into the radio and talk to someone maybe within our country or outside of the country over the airwaves. So we have a microphone that generates an audio frequency. We have the mixer that we talked about and the local oscillator. And our audio frequency is added to a carrier and it modulates that carrier, and we end up with a frequency that is transmitted that is modulated by our voice. So If we were to look at the right-hand side here, we'll notice that, in all cases, let's look at the left-hand side here, first of all, right? Amplitude modulation. We start with our voice, or what we call our input modulating wave. We have the carrier frequency, which is what our dial is tuned to, whatever frequency we're transmitting on. But when we apply our voice or the modulating wave to the carrier or the tune frequency, we end up with a modulated result. And this is what goes out over the airways. So this is generated inside of the radio. The amplifier boosts it up to, several watts, several hundred watts maybe, and it goes out to the antenna, and the antenna radiates that signal depending on the type of antenna, and another person will receive our signal. But notice that we can modulate in different ways. We can amplitude modulate, so the signal will look like this. Or if we use the same voice signal and the same carrier frequency, we can use frequency modulation, and notice how the wave looks when we modulate the frequency. And just as an extra here, we put in for you for digital modulation, because we did talk about digital voice. This is what digital modulation looks like when we apply a digital signal, a digital representation of voice, to our same carrier wave, and it modulates it like this. So this is just a visual representation, all to say that we have a frequency that is generated on our radio, and our voice, or whatever signal we input, modulates that frequency to end up with the frequency that is eventually sent out via the antenna. So bear in mind, we have to modulate that frequency to impart the information on it so that it can go over the airways, so that somebody could receive that signal and extract that intelligence or information. It could be voice, or it could be a digital signal. However, Murphy's Law, when things can go wrong, it will go wrong. So in amateur radio, we also have to be concerned with the things that can go wrong and do go wrong. And one of those things is called interference, radio frequency interference, or even harmful interference. Interference. But what causes interference in the amateur radio world? So we will look at three things at this time. The first thing that causes radio frequency interference is what we call the fundamental overload. And what fundamental overload is? A really strong signal that can overload a receiver, right? Think of it as two persons talking in a room, and they are talking at a normal tone of voice. They're not very loud, they're relatively soft, but they're talking to each other. Imagine for a moment that another person enters the room and suddenly starts to shout. Will the two persons be able to hear each other? Or will the person who is listening to the first speaker be able to hear them? Probably not, because that second person who entered the room came in and started to shout. So what they have done was overload the receiver by another strong signal. And that is what happens in radio as well. If you have a transmitter that is outputting a very strong signal, it could overload the receiver to the point where the desired signal is not heard or sounds very distorted. So that is what fundamental overload is. It can be caused by the receiver's inability to reject the out-of-band signal. So again, it's just like the person in the room. You're listening to a person talking to you, but this person just comes in and starts to shout, and you cannot make out the difference between what the person who is sitting in front of you is telling you versus that person who is just nearby shouting. You are not able to discern the difference. So you, as the person as a receiver, is unable to reject the out-of-band signal. Also, it's often experienced. Remember, we said a little earlier, you get what you pay for. That fundamental overload is exacerbated when you use inexpensive, let's use the word cheap, receivers that have limited filtering so that they become susceptible to interference. So again, when you are in the market for purchasing radios, equipment, and you see one radio is 400 US and the other radio is 1,000 US, you say, well, I wonder what's the difference, because it have the same features. Look at your specifications. One may have more filtering than the other that prevents you from receiving as much harmful interference. So bear that in mind. Fundamental overload is one of the causes of radio frequency interference. Another one is harmonics. And what are harmonics? So a harmonic is defined as an integer multiple of a fundamental frequency that can fall on the same frequency as a desired. All right, so that is a little bit complex in what it is saying, but it is simple. Let's use a diagram to illustrate what a harmonic is. So if I have a frequency, and this first frequency here I've listed is 110 hertz. Let's say that's the frequency. The second harmonic is 220 hertz. The third harmonic is 330 hertz. The fourth harmonic is 440 hertz. The fifth harmonic is 550 hertz. Can you guess what the sixth harmonic is? If you guess it would have been 660 hertz, you'd be correct. So you get the picture. A harmonic is just a multiple of the fundamental frequency. So whatever frequency you have, just multiply it by 2, and then multiply it by 3, multiply it by 4, and you will get the what we call the harmonic frequencies. The reality is that when you generate a frequency, harmonics are naturally generated. So you only intend to generate a frequency on 3.815 megahertz. But guess what? When your radio is generating that, it will also generate twice that, and 3 times that, and 4 times that. Usually very small in comparison to the fundamental frequency, but bear in mind that is how radio works. There is what we call harmonics to any signal, and harmonics are a source of radio frequency interference. The third cause of radio frequency interference that we will discuss is spurious emissions. Now, I'll quick to point out that sometimes harmonics are considered spurious emissions. So that's why that last bullet point is set here, right? So some of these terms, depending on who you talk to, depending on the book you read, will sometimes muddle these terms a little bit, which is fine. But just bear in mind that spurious emissions can refer sometimes to harmonics, right? So if you see that somebody says, you know, a spurious emission example is a harmonic, don't be worried. That's just fine as well. But a spurious emission sometimes could refer to radio frequency leaks out of equipment. I mean, there's so many things that can result in spurious emission, but just for your reference, think of it like a leak of radio frequency out of the equipment because maybe it's not properly shielded. Remember we had discussed shielding. So we have a diagram here, show a metal shield around a piece of equipment, a stage of the receiver, for instance, or transmitter. Well, if that shield is not solid enough, some of the signal could leak out and you may have that spurious emission. So you could think of it that way, for instance. All right, so given the type of interference that we do have, what can we do to resolve some of these interference issues that occur with us, right? So the first thing that we could do is, if interference is occurring, somebody reports, hey, you know, you're interfering with their radio or TV and so on, check yourself, check at your house, your home, your site. See if you yourself are getting that interference. Let's say someone tells you that they're tuned to channel 13 on their TV, your neighbor, and they're saying, you know, we know you're an amateur radio operator, and every time you talk, we see, you know, our TV, you know, it's not cable that they're using direct channel 13. And the signal, if you look on the right-hand side here, the screen starts to turn all different colors and move around and so on. You could check your television set on channel 13 and see if when you talk that happens to you, right? So that is one of the things you can do. You can check to see if the interference is occurring by you, because if you are causing interference by a neighbor, you might be causing interference by yourself. The thing is, your neighbor might have a different television of a different quality to yours. Remember, we talked about, we will discuss that in a little bit. You know, there are different quality of receivers and so on, and some of them are more prone to interference. The other thing you can do is check all your connections. So for instance, the television itself, maybe the coaxial cable at the back of the TV is loose, or maybe it's not properly made and so on, and that is causing, you know, signals to interfere. So that's the other thing you can do, check all of your connections. Always verify. As an amateur radio operator, when you connect your equipment together, one tip is every now and again, double check your connections. Note, you don't want to have your transmitter active when you check in your connections, right? Remember we talked about RF burns? So you want to avoid the possibility of that. You can also see or check to see if the receiver is being affected by a strong transmitter signal. Remember we talked about overload and so on that can occur because the receiver might not be able to reject the strong signal. So just bear in mind, you can check that. One tool or one technique that you can use to mitigate or reduce interference is by the installation of what is known as filters. So you can install filters, and the filters, you can block strong amateur signals with a filter at the antenna input of the affected receiver. So if it's a radio or television, you can get filters and put them at the back of the television, for instance, to reduce those signals. You can also block the strong amateur signal with an RF filter on the telephone if it is telephone interference that you're getting. You know, you're on the phone and you're hearing the amateur radio transmission. There are filters that you can apply to the telephone. Yet another filter that you can install is now on your radio side. So the output of your transceiver, your transmitter, you could install a band reject filter on your output that will reduce the interference that you are likely to be causing. So all of these are ways that you can resolve radio frequency interference. Well, that's you as an amateur possibly causing interference. But what about if you are receiving interference from your neighbor, and your neighbor may not be an amateur radio operator, right? Or someone in a different apartment or a different room as to where you are, you're getting interference. Well, interference can be received by you as an amateur radio operator, and it can come from what we call unlicensed devices, also known as FCC Part 15 devices. So for example, a mouse, a wireless mouse or cordless mouse, you don't have to go on, when you buy that mouse, you don't have to go to TAT, for example, and get a license to use the mouse, right? It's a Part 15 type device. So it can still cause interference to you, even though it's an unlicensed device. So you can check for that. And the point that we make here is that unlicensed devices that emit low-powered radio signals on frequencies used by a licensed device. It can happen. So it's unlicensed. Sometimes in Trinidad and Tobago, we refer to them as class licensed devices, right? They may emit signals that could cause you as the amateur interference. All right, so if you have ever seen this label on a device, you could look below your mouse. You might see it saying FCC ID number, and it will says this device complies with Part 15 of the FCC rules. All right, so when we talk about a Part 15 device, that's what we mean. FCC, Federal Communications Commission, Part 15 device. And what that simply means, it's an unlicensed device. But what if we do get interference? What can we do? Do we go and try to rough up the neighbor and say, hey, you're causing interference to my amateur station? No. That is not tolerated at all. That's not the attitude. That is not the correct way. What do we then do? Well, we be nice. We be cordial. So the point that is made here is if a neighbor's home is causing harmful interference to your amateur station, one, check your station to make sure it meets the standards of good amateur practice. Make sure all your connectors are tight. Make sure you use good quality cable. If you're using poor quality cable, you might be inviting interference into your own station. So, check yourself first. That's what the first point is, before you go and look for your neighbor to see what they might be, causing you. Make sure that you have a properly installed amateur station. That's your responsibility as a licensed amateur radio operator. That's why you also train. That's why you go after certification, and that's why you get a license. You have a responsibility. But what if, your equipment is good and it's something coming from your neighbor? Again, be nice. Work with your neighbor to identify the offending device. Work with them, a very nice, cordial relationship. You're not going to shout at anybody and so on, right? You are going to be very nice, which is the third point. Politely inform your neighbor about the rules that prohibit the use of devices that cause interference, right? And if you look at what this FCC tag says, it says Part 15 devices. One, this device may not cause harmful interference. And two, this device must accept any interference received, including interference that may cause undesired operation. So that's what a Part 15 device is. So the point is you can troubleshoot, but be very nice, please. There are also some common problems that you will encounter as an amateur radio operator. You may have noisy or distorted audio when you're transmitting. So for instance, your transmitter may be slightly off frequency. So you have this on your dial, 7.025.00, but maybe there's something wrong with the alignment of your radio and it's not actually transmitting on this frequency. Or you might have inadvertently, you didn't lock the VFO knob and you or someone else just touched it slightly. And when you examine it and see, you're seeing 7025.03, you're off frequency. So you just put it back on frequency. But if you're off frequency, that is one reason you can sound distorted. Also, if you're using batteries for your transceiver, it could be a handheld device or your base station using batteries. If it's running low, that can cause a noisy or distorted audio when you're transmitting. People will say, okay, your transmission is noisy or your transmission is distorted. That's another reason. Yet another one, bad location. You may have a poor location and your signal as a result of that is very low when received by the person you're talking to. So you can try and change your location if you're doing portable, mobile operation, portable, or you're using a handset. You could relocate. So bad location could be the reason why your signal is sounding noisy or distorted. We also discuss here that radio frequency or RF in a transmitter or transceiver can cause voice transmissions to be garbled, distorted, or unintelligible. In other words, problematic with your audio. Now, sometimes, just sometimes, the reason for garbled or distorted audio when you're operating on the FM mode in particular is what we call over deviation. Remember we said, with FM, it actually modulates the frequency. Well, if you are too loud into your radio, shouting in your radio is too close and your audio gain, for example, on your microphone is high, you might be over deviating or over driving in your radio. You may be speaking too loud. So one of the techniques, and this you'll find in your question pool as an exam question, one of the techniques that you can use is to talk a little further away. Sorry about the spelling. Yeah, there's some little errors, typos. I do apologize for that. So you can talk a little further away from the microphone to reduce the overdriven audio. Just back it off. If your microphone was, let's say 3 inches from your mouth, you can just back it off, try 6 inches, and that should reduce the audio level into your microphone, and that can sometimes clear up that garbled or distorted audio if you're operating on FM. So we have a couple of instruments that we utilize as amateur radio operators. We have the multimeter that can do multiple functions, and 2 typical measurements that we use the multimeter for is for voltage and resistance. A voltmeter measures voltage, and you connect a voltmeter in parallel across the component that you want to measure the voltage. Remember we had used the water circuit as an analogy when we were discussing the electronic principles, values, and so on. Well, it's the same thing. You put the voltmeter in parallel across the device that you are measuring. So remember that voltmeter measures voltages, and it's in parallel when you're doing the measurement. Also note that the leads that you use must be rated for the voltage that you're measuring. So do not use leads that are not intended for the particular voltage. So if you're doing high voltage measurements, use leads that are appropriate for the voltage. Otherwise, that could be very dangerous if you use underrated leads or cables. An ohmmeter measures resistance. And how it works, if you remember Ohm's law when we did it, I think first or second class, it applies a known current to a circuit, it measures the voltage, and therefore, because it knows the voltage and the current, it calculates the resistance by using Ohm's law. So that's how an ohmmeter works. But please, when you're using an ohmmeter, please make sure that the circuit is not powered. You're trying to measure resistance. You do not want the presence of any voltage there. You could damage your meter if you attempt to measure voltage on the resistance setting. So some of us have been there, done that, and have had a very expensive experience. If you are measuring a circuit and at first you see that the resistance looks low and then it increases, What that possibly means is that there's a capacitor possibly in your circuit. Remember, we dealt with what a capacitor was. It holds a charge. So when you put the leads on, it might be charging up that capacitor so that you get the low resistance reading. But when it's fully charged now, you find that you have an increased or high resistance. That is the telltale sign that the circuit has a capacitor. Again, you'll get this question in the question pool. An ammeter measures current. And note that when you're connecting an ammeter, unlike a voltmeter, remember we said we connected in parallel? Well, an ammeter that's measuring current, you connect it in series, right? So notice where you put the ammeter, it's in series with the circuit. Right, solder. What is solder? So if you were to ever open up any device that has a circuit board in it, you will see components, and you'll see the components on a board. It usually is green, it could be red, but the component leads are tacked to the board using what is called solder. And this is a roll of solder, what we call rosin core solder. And solder, if you were to look across sectional area, you will see that there's this, the actual solder on the outside and the inside, we have what is called rosin core to help with bonding when we solder. We also need to know what a good solder joint looks like and a bad solder joint. And a bad solder joint is called a cold solder joint. So when we say a cold solder is a bad solder. So if you look at these two series of joints here, notice these here are very, grainy and whatever. These are bad solder joints. Notice that the good solder joints tend to look very shiny and reflective. We will take a 2-minute break. So please take a stretch, have some water, do a bathroom break, and we'll come back in about 2 minutes time. Okay, welcome back everyone. So we go straight into the no nonsense guide. If you are following on the PDF, it's page 65. If you are printed, it's page 60. So we have touched on pretty much all of the theory during the slide deck. So we will look to move quickly through the questions in the question pool. There might be one or two questions that we did not do all of the theory related to the questions. If so, we'll probably just do a couple of teaching moments in there. But all of the slides, as presented earlier today, should take care of some of the explanations and theory associated with these questions in the question pool. So let's dive straight in and see if we could complete these questions in this section. First question is, what is a transceiver? A transceiver is a unit combining the functions of a transmitter and receiver. Transceiver. Next question. What device converts the RF input and output of a transceiver to another band? Remember we had shown where we use a transverter and we connected a radio to it and to the antenna, and we said it's working bidirectional to convert from one frequency to another. So that's what they mean here by RF, radio frequency input and output. So the answer to this question is a transverter. Next question. What device increases the low power output from a handheld transceiver? So we had a slide in the slide deck to show this visually. That device is an RF or radio frequency power amplifier. Next question. What is the function of the SSB FM switch on a VHF power amplifier? Now, notice there's the CW inside of there. The one that we did look at, it just said SSB FM. So notice that that button could be called SSB/FM or SSB/CW FM. What is the function of that button on a VHF power amplifier? It sets the amplifier for proper operation in the selected mode. Remember, we had said that SSB signal is a little bit choppy on off as opposed to FM, which is continuous. Well, you need to tell your amplifier it's an SSB signal so it doesn't start stop with the SSB signal. You want to make sure that it knows that it's an SSB mode signal that is coming into the amplifier, so it will amplify it properly. So the answer is, it is to set the amplifier for proper operation of the selected mode. So if you're using the amplifier for FM mode, make sure it's set to FM. If you're using the amplifier for SSB mode, make sure it's set to that setting. All right, moving right along. Next question in the question pool. Which term describes the ability of a receiver to detect the presence of a signal? Right, so remember we talked about some specifications. So which one is it? The one that detects the presence of a signal. The answer is how sensitive. So sensitivity. To be able to detect the signal, it needs to be sensitive. So that answer is sensitivity. So the next question, by process of elimination, which term describes the ability of a receiver to discriminate between multiple signals? In other words, which one allows you to pick out one from the crowd or to select one from the crowd? Naturally, it's the selectivity specification, right? Where is an RF preamplifier installed? So if we were to go back to the diagram or the picture that showed the amplifier with the preamp button, we will see that that preamplifier is installed between the antenna and the receiver. So that's the answer. If you need to convince yourself of that, just have a look back at the slide deck. Moving right along. Which of the following is used to convert a radio signal from one frequency to another? So this is the slide that looked at the concept of mixer and oscillator. So it's converting a radio frequency that's coming into the antenna to another one that goes to the output, which is the IF stage. Well, the component that is used to do that is called the mixer. All right. And inside that same diagram, we're looking at another component. What is the name of the circuit that generates a signal at a specific frequency? All right, so remember the component that we said was doing the generation is called an oscillator. So that's the answer. The component that generates the signal inside of your radio at a specific frequency is called the oscillator. Next question in the question pool. Which of the following describes combining speech with an RF carrier signal? All right, so let's look at this question in a little more detail. Let's dissect it a little bit. Which of the following describes combining speech? So that means we have voice with an RF carrier signal, or the carrier wave, right? We have a carrier and we want to combine speech. What are we trying to do? We have the audio signal and we have the carrier signal, and we're combining them. Remember we said that that speech modulates the carrier signal? Well, that's exactly what we are doing. So the process that describes combining speech or audio or voice with the carrier signal that's generated in your radio is called modulation. Remember we said we had digital modulation, we had amplitude modulation, frequency modulation. So all of them are modulation. Oh, and they just give us this little note here that modulators are actually a type of mixer circuit, or it uses a mixer circuit to accomplish the process. All right. Remember Murphy's law? Some people say Murphy was an optimist. Right, question in the question pool. Which of the following can cause radio frequency interference? Well, we dealt with this on a slide, and we said that these are the causes or possible causes of radio frequency interference. So all of them are correct. So that is the answer. Fundamental overload, harmonics, and spurious emissions. Remember, we looked at what each one was. So for your question in the question pool, you need to know that these three are in fact correct. All right, so let's get to the questions about being a good neighbor. Which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? In other words, you're causing them interference. Which of the following actions should you take? Well, you can make sure that your station is functioning properly and that it does not cause interference to your own radio or TV when it is tuned to the same channel. So that's one thing you can do. If your neighbor tells you that you're interfering with them, check if you're interfering with your own radio and TV. Next, what should be the first step to resolve cable TV interference from your ham radio transmission? All right, so it's asking if your amateur radio transmitter is causing interference on your TV or cable TV. What's the first thing you should do? First suspect, be sure that all TV coaxial connectors are properly installed. In other words, look at all connecting your cable box or your TV antenna or whatever that goes to the back of your TV, switch boxes and so on. Make sure that all of those connectors are proper, tight, and properly installed. If they are loose, then those could become antennas to attract your amateur radio signal into it. So make sure that those connectors are properly installed. Make sure that it's fully in and tight. Make sure it's not only the center pin that's connected and that your the screw terminals are loose, because that means you only have one connection and the shield isn't working too well. You need to push it all the way in and tighten it. So make sure that the TV coaxial connectors are properly installed. All right. What would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? So let's say that again. What would cause a broadcast AM or FM radio? So that's like your transistor radio in your house or in your car or whatever. What would cause a regular AM FM radio to receive an amateur radio transmission unintentionally? In other words, unintentional interference is being caused by your amateur radio transmitter to a broadcast receiver, regular AM FM radio, for instance. What could cause that? Well, it could be the quality of that radio. So the receiver, meaning that your AM FM radio, is unable to reject strong signals outside of the AM FM band. Remember we said sometimes they don't have enough protections, filter circuits, and so on. That could be the case. How can overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? So let's say that again. How can overload of a non-amateur radio or TV receiver, that's simply your television set or your stereo set at home. That is what is meant by a non-amateur radio or TV receiver. By an amateur radio signal be reduced. In other words, amateur radio transmitter is causing an overload in a stereo set or TV in the house. How can that be reduced or eliminated? One of the things you can do is block the amateur signal with a filter at the antenna input of the affected receiver. In other words, your TV or your stereo set, you need to put a filter. That's what this is saying. Next question in the question pool. Which of the following can reduce overload to a VHF transceiver from a nearby FM broadcast station? All right, so you have your amateur radio VHF transceiver, but you are getting interference from, let's say, 95.1. Not to pick on them, but it's a good radio station. FM broadcast station is causing interference on your VHF radio. What can you do? You can install a band reject filter on your transceiver so that it will reject that FM broadcast traffic, right? All right, so we're going through these questions pretty quickly because we dealt with all of the theory in the slide deck. Which of the following is a way to reduce or eliminate interference from an amateur transmitter to a nearby telephone? In other words, the amateur radio is causing interference to the telephone. How can you reduce that? You can put an RF or radio frequency filter on the telephone, and that will reduce or could reduce the interference from the transmitter, the amateur transmitter. All right, so filters are an answer to the problem. Moving right along, next question. Which is a part, or sorry, what is a part 15 device? All right, so remember we said FCC part 15 devices are an unlicensed device that may emit low-powered radio signals on frequencies used by a licensed service. So remember we had this slide in the slide deck, we had a mouse, I think it was, and we said that's a part 15 device. Yeah, well, those things do emit, it can emit radio signals and cause some interference. So we just need to know what a part 15 device is. It's an unlicensed device. What should you do if something in a neighbor's home is causing harmful interference to your amateur station? So we did have a slide of things that you can do, remedies, right? If you get interference from your neighbor, maybe from their part 15 device. Remember we said be nice? All three of these are correct. Work with your neighbor to identify the offending device. Politely inform your neighbor about the rules that prohibit the use of devices that cause interference, and check your station and make sure it meets the standards of good amateur practice. Matter of fact, I will do the first one, the last one first. Let's make sure that we are good and we are not prone to receiving the interference, right? Nicely. What might be a problem if you receive a report that your audio signal through the repeater is distorted or unintelligible? In other words, you're talking to someone and they tell you you're sounding bad, you're distorted. Well, we did have a slide in the slide deck that gave these three recommendations, and it says that all of the choices are correct. The first one is your transmitter is slightly off frequency, right? Just tune it back on or realign your transmitter. Maybe your battery is low, charge it up. Or you're in a bad location, relocate. Okay. What is a symptom of radio frequency or RF feedback in a transmitter or transceiver? What is a symptom if you have RF feedback? People will report to you that you have garbled, distorted, or unintelligible voice. That is how you will know you probably have RF feedback in your transmitter. Others will tell you about it. What can you do if you are told that your FM handheld or mobile transceiver is over deviating, right? So when we talk about deviation, we refer to the FM mode of transmission. If somebody tells you you're over deviating, what can you do? Well, that means you're sounding maybe distorted and so on. You're driving that microphone too hard. What you can do is talk a little farther away from the microphone. Okay. Next question in the question pool. Again, we did all of this theoretical concepts on the slide deck. So we will just quickly go through these questions. All right. Which of the following measurements are commonly made using a multimeter? We said two common measurements are voltage and resistance. Which instrument would you use to measure electric potential or electromotive force? In other words, which instrument should you use to measure voltage? The answer is a voltmeter. Remember during the previous sessions, we talked about electromotive force and electrical potential being measured in volts. Well, what do you use to measure voltage? A voltmeter. What is the correct way to connect a voltmeter to a circuit? So we showed diagrammatically, it has to be connected in parallel with the circuit to measure the voltage. Again, a lot of these later on classes do depend on the prior knowledge gained in earlier classes. So if any of these terms, parallel, series, anything that we talk about unclear, just simply review the previous classes to, refresh. That's all good. You'll see the connections as you review. Which of the following precautions should be taken when measuring high voltages with a voltmeter? Right, so this is a safety question. What precautions should you take? We need to ensure that the voltmeter and the leads are rated for the use of the voltages to be measured. Don't go and try to measure a 2 kilovolt, with a device that's just rated at 600 volts. That's very dangerous, and you can get killed with high voltages if the insulation breaks down. It cannot handle it. So please, always make sure that the voltmeter itself and the leads that you use are properly rated. If you look at the leads, it will tell you, okay, 600 volts rated. Make sure that whatever you're measuring is well under that rating. What instrument is used to measure resistance? Remember, resistance is measured in ohms. So the instrument is called an ohmmeter. Which of the following precautions should be taken when measuring circuit resistance with an ohmmeter? right? Well, you don't want to damage it, right? So make sure that the circuit is not powered because you're measuring resistance. You're not measuring voltage or current. You're measuring resistance. So make sure it's powered off. Which of the following might damage a multimeter? Again, some of us have actually done this. You might inadvertently, hopefully, and it's not deliberate, you might be attempting to measure voltage when you are on the resistance setting. Please do not make that mistake. It will be a very expensive mistake. What is probably happening when an ohmmeter connected across an unpowered circuit initially indicates a low resistance and then shows increasing resistance with time? So you're probably thinking, there's that component that does that, that stores a charge, right? So you apply the voltmeter to it or the ohmmeter to it, it shows a low resistance and all of a sudden now it goes right up and shows a high resistance. Well, remember that little component we talked about, the capacitor? That's it. The circuit contains a large capacitor is the answer. What instrument is used to measure an electric current? The instrument is called an ammeter. And how is a simple ammeter connected to a circuit? Well, it's current that we are measuring, so it has to be in series with the circuit. Which of the following types of solder is best for radio and electronic use? Well, we talk about rosin core solder, right? So if we're doing work, use rosin core solder if it is that we are doing soldering of any kind. What is the characteristic appearance of a cold solder joint? Remember, cold solder joint is a bad joint, meaning it's not very effective. It wouldn't conduct properly. It might have a high resistance. Matter of fact, the component might even be connected to the circuit at all, right? So a cold solder joint is a bad joint. How can you tell what a cold solder joint is? How does it look? It looks grainy or dull. As opposed to a good solder joint, when you make it, it looks very nice and shiny. You might be able to see your face in it. So that's it for today. We will end on page 66. I think we covered all of the slides and the questions. So next day, we'll come to the next topic, which is operating procedures. So certainly would like to encourage persons, if you have not already attempted the practice exams, highly recommended at this stage. Please consider taking those practice exams. Session number 1, the slides in the slide deck has the links to all of those practice exams. We have been getting very good reports from several of the students in the class, passing exams already. So that's very good, very encouraging. Our next session will be held on Friday, the 28th of August at 8:30 p.m. You will receive an email as usual. I would like to take this opportunity to wish everyone a good weekend. And also, please, everyone, be safe out there. And we see what's happening with respect to COVID-19. So each of us have a responsibility. So just want to encourage us all to continue to be safe. So everyone, do have a good night. All the best.